We're going to be doing the Conic section project. My name's Maylai.
My name's Kevin.
I'm Estefania. And I'm Alejandra.
My name's Maylai and I'm going to be explaining the Conics project for a circle. So here we have two cones and a plane, and inside we would get the shape of a circle. So our standard equation would be x minus h squared plus y minus k squared equals radius squared. And our general form would be x squared plus y squared plus ax plus by plus c equals 0. And this would be our circle shape. Now we have some examples from the real world, which is a CD, some tape, and a bracelet, which are everyday things where we find circles. The definition for a circle is the set of all points in a plane that are at a fixed distance from a given point. Some natural circles from historical events were the moon and the sun. And the circle derives from the Greeks kirkos, meaning hoop or ring. Another definition from the Euclid element books is also a circle is a plane figure bounded by one line and such that all right lines drawn from a certain point within it to the bounding line are equal. The bounding line is called the circumference and the point is the center. So here I'm going to do an example with the circle equation. So this would be the standard form, and my example would be just to plug in some points here. So I'm going to plug in a 3 and a 2 for my B. And I'm going to plug in a 25. So now I would just get my center and my vertex. In order to get my center and vertex, I would equal x minus 3 equal to 0 and y plus 2 equal to 0. And I would solve it. So my x, you would move the 3 to the other side, so x would just be 3 and y would just be negative 2. So then my vertex, you would just put x and y. So now you just replace your x to 3 and your y to negative 2. Now in order to find my radius, I would have to get the square root of 25. So when I get the square root, I get that my radius equals, the square root of 25 is 5. So we can rewrite the 25 as 5 squared. Now we're going to try to plot some points. So remember that your center and your vertex mean the same thing. So I would plot my vertex at 3, negative 2, which would be here. And now, since my radius is 5, I would just go up 5 units, to the right side 5 units, to the left side 5 units, and down 5 units. So if I go up 5, I would go 1, 2, 3, 4, 5. And my point would be at 3, 3. If I go to my right side, my point would be at 8, negative 2. And if I go down, my point would be at 3, negative 7. And if I go to the left side, my point would be at negative 2, negative 2. So from here, we can draw our circle. And this would be the circle equation with our standard form, our vertex radius, and this is how we would graph the circle.
So today's conic section is going to be on parabolas. So a parabola comes from when a cone is intersected by a plane and it forms a parabola in the middle. And a parabola, as you can tell, it's an arc-shaped curve, but it is a set of points that are equal distance to the focus and a line called the directrix. Okay, so now that we know the definition of a parabola, we're going to construct one using its definition. So here I have the focus and the directrix, and if we fold across, what it does is that it marks the points where it is at an equal distance from the focus and from the directrix. So it just starts marking a bunch of points around here, and it starts forming the parabola you see right here, which is this one, after you keep folding. So that's the definition of a parabola. Okay, so the equations that form the parabola is this one and this one, and this one's called the standard form, but it's also known by the quadratic equation. And this one is known as the vertex. Okay, so now that we know what a parabola looks like, let's graph it. But first we have to look at the critical points. So first off, the vertex, we find it by using this equation. So we just we substitute the numbers into there, and then the x-intercepts, we equal the whole equation to 0, and for the y-intercepts, we equal x to 0. So let's do this example. For the vertex, we're going to do b over 2a. So b is 2, so it will be negative, because there's already a negative in the formula, with a negative 2 over 2, 1, because there's a 1 here, because a can't equal to 0. And that becomes a positive, and that's 2, it reduces to 1. Okay, so now that we know that, that's going to be for the first one. Now we just substitute 1 into x. So it will be f of 1 equals to 1 squared over, minus 2, 1, 8. So this is 1, this is 2, this is 8. So it will give us negative 9. For the x-intercepts, we have to equal the whole equation to 0. So what we're going to do, we're going to factor them out. So we find two numbers that multiply give you 8, and when you subtract them give you negative 2. So that's x minus 4 and x plus 2. So then that's x equals to 4 and x equals to negative 2. So those are for our x-intercepts. For the y-intercepts, we just substitute x for 0. So that's going to be 0 squared minus 2 times 0 minus 8. So that's 0. 2 times 0 is 0. So it's just 8. Negative 8. Now that we have the points, we can just plot them. Okay, so the y-intercept is going to be negative 8. So that's negative 8. And then x equals 4. And x equals to negative 2. And then the vertex is at 1 and negative 9. So that's 1, negative 9. So right here. So that's a parabola.